Today we're going to start with coordinate proofs in geometry. We did them before with the parallel lines and perpendicular lines. However, now we're going to focus more on proving certain shapes and certain statements that we have in our examples here. The title of this lesson is 10.3 Coordinate Proofs. We're specifically talking about triangles today, and we're going to do 4 examples with this. So, the first example states we're given that we have a triangle. We're actually trying to prove that two angles are congruent. We are given these points, so I'm going to go ahead and place them on our graph. I'm given J, which is -4, 1. I don't exactly know what shape I'm supposed to make yet. I'm assuming triangles since that's the title of the lesson, but we'll see in a minute. So I'm not going to connect anything yet. K is 0, 5. L is 3. That should be a comma right there. L is 3, 1. M is -1, -3. Okay, like I said, I'm not going to connect anything yet. I could actually look right here and see what's going on. I'm going to have the JSK. I don't have S yet. And LRM, and I have L and M, but I don't have an R yet. Alright, so I actually need to find the point R and the point S. So it says R is the midpoint of JK. Well, the midpoint formula is the basically average of the two, or -4 the x of J plus 0 divided by 2, and the y's 1 plus 5 divided by 2, which means R is located at -4 plus 0 is -4 divided by 2 is -2, and the y value 1 plus 5 is 6 divided by 2 is 3. So R is at -2, 3. So I'm going to go ahead and graph -2, 3. That is R. Alright, I'm going to go ahead and find S as well. Same process. It's just now it's at midpoint of LM. So 3 plus -1 over 2. And 1 plus -3 over 2. Likewise, I'm going to simplify that. So S, the x coordinate is S plus 3 plus -1 is 2 divided by 2 is 1. And 1 plus -3 is -2 divided by 2 is -1. So I'm going to go and graph 1, -1. There is S. Alright, now this is what I'm given. I specifically need to prove that I have two congruent angles. So to prove that I have two congruent angles, first of all, I need to draw this so that I have these angles. So I'm going to draw J, S, and K. J to S, S to K, and I'm just going to go ahead and make it a full triangle here. There's my first one, JSK. Let's go ahead and graph the next one, LRM. Alright, I've got two triangles here. What I'm actually trying to prove is that JSK, this angle right here, is congruent to LRM, this angle here. Now, so far in your geometry curriculum, you have not learned how to find these angles yet. So we, in order to prove this, are first going to have to prove that we have congruent triangles. And then, if we have congruent triangles, our corresponding parts will be congruent. So to prove that these triangles are congruent, since I have a coordinate plane, I can find the lengths of every side and show that since the side lengths are congruent, I have two congruent triangles by the side, side, side triangle congruence theorem. So let's start with triangle JSK. And we're going to find the length of JK. And we're going to find the length of KS. And we're going to find the length of JS. we're going back to the points that are over here to find them using the distance formula. And in case you have forgotten the distance formula at this point, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So this is the formula we're going to be using to find the lengths of these. So jk, let's say j is x2 and y2. So I have negative 4 minus, and I'm finding k, 0 squared plus 1 minus 5 squared. And I'm going to come back and find that in just a minute. I'll plug in. I'm going to use the calculator for that and plug it straight in, actually. All right, ks. I'm just going to go ahead and set them all up. Here's k, and here is s. So 0 minus 1 squared plus 5 minus negative 1. Minus a negative is plus 1 squared. Again, I'll come back and find that in a minute. Then let's go with js. Here's j, here's s. I've got negative 4 minus 1 squared plus 1 minus negative 1 is 1 plus 1 squared. Alright, now, using your calculator, I'm actually going to plug these straight in like this. You can do it by hand. It does not hurt you to do it by hand, but I'm going to plug it in just like it is. So I've got the square root of negative 4 minus 0 squared plus 1 minus 5 squared. And I'm going to round to the nearest tenth just for these purposes because I'm just trying to make sure they're actually the correct lengths. So again, ks, I've got 0 minus 1 squared plus 5, might help if I put it in parentheses, 5 plus 1 squared. And this one is rounded to the nearest tenth, 6.1. And js, square root of negative 4 minus 1 squared plus 1 plus 1 squared. And again, rounded to the nearest tenth is 5.4. Right, so here are 3 lengths for this triangle. Let's find the lengths for LRM and see if they're the same. I'm going to do those right underneath here. So with LRM, I've got LR, I've got RM, and I have ML. And my goal is that hopefully one of these will match up with one of these over here. So LR, here is L, here is R. I've got 3 minus negative 2, which is plus 2, squared, plus 1 minus 3 squared. I'll plug that in a moment. RM, I've got negative 2 plus 1 squared, because it's already a negative with M, plus 3 minus negative 3, so plus 3 squared. I'll plug that one in a minute as well. Kind of crooked there. There we go. All right, ML. M and L. 3 minus negative 1, which is plus 1 squared, plus 1 minus negative 3, which is positive 3 squared. Alright, I'm going to go back and plug these in just to make sure we do have something that is correct. So 3 plus 2 squared plus 1 minus 3 squared. I've got 5.4, and there we go. We've got a pair of congruent segments. So since I've got that, I'm going to go ahead and write that. I know that JS is congruent to LR. Okay, now let's type in RM. Negative 2 plus 1 squared plus 3 plus 3 squared. 6.1, got another one. KS is congruent to RM. We'll comma here, KS is congruent to RM. Alright, and ML, hopefully it should be 5.7, come out like JK. 3 plus 1, I need parentheses. 3 plus 1 squared plus 1 plus 3 squared is 5.7, just like JK. So last I have JK is congruent to ML. Alright, using these statements here, we are supposed to prove something. I'm going to write this over here. It's our last and final statement here. Since the 3 side lengths of each triangle are congruent by the side-side-side triangle congruence theorem, triangle JSK is congruent to triangle LRM, and therefore angle JSK is congruent to angle LRM because corresponding parts of congruent figures or triangles are congruent. So there's the first example. Those examples take a few minutes in case you cannot see. However, they are easier, not easier, but they're different compared to the other triangle congruence theorems we have, proofs that we have done in the past. Alright, number 2, the second example here is the same. If you are working on this yourself, it's a good idea to pause the video here and start this one yourself before we do it together. But I will go ahead and start this one now. Just like before, I'm going to go ahead and graph all of these points and then see what we've got going on. So A is at -4, -2. Again, I'll connect them when I know what I need. B is at -3, 2. And C is at -1, 3. Okay. If I go ahead and look over here, I know I've got BCA, so I'm going to go ahead and connect those 3. And I'm going to go ahead and graph. I've got EFD, it says, so let's start with D, -5, 0. D, -1, -1 is E. And 0, -3 is F. I'm hoping they kind of look the same so that I've got congruent triangles. They do look kind of the same here. Alright, and just like before, I've got to prove that these angles are congruent, and in order to do that, I have to have 2 congruent triangles. So the process we did up here is the same as what we were fixing to do now. So, let's just go ahead and get started. Let's work with BCA first. So that means I have to find the side lengths of AB, BC, and AC, again using the distance formula. AB, I've got -4 plus 3 squared plus -2 minus 2 squared. And those points are coming from these values over here. I'm not sure you can see it yet. You can see them all now. Okay. BC is -3 plus 1 because it's a negative squared plus 2 minus 3 squared. And AC is negative 4 plus 1 squared plus negative 2 minus 3 squared. While I'm setting them up, I'm going to go ahead and set up the other three sides of this triangle as well. Remember, since I have this on a coordinate plane, it just is going to be easier. The best way to prove that these are congruent is through the distance formula and side triangle congruence theorem, which is why I have to find the lengths of all the sides. Alright, so DE is negative 5 plus 1 squared plus 0 plus 1 squared. And EF is negative 1 minus 0 squared plus negative 1 plus 3 squared. Remember, the formula is minus. I'm only putting plus because it was a negative value there. Draw my straight edge. Alright, so DF then, negative 5 minus 0 squared plus 0 plus 3 squared. Alright, now that I have them all set up, I'm going to type them in and see if I've got any that are congruent. I could look over here and see which ones I think should be congruent, but we're not going to do that. We're just going to go ahead and type these in and see what's going on. So I'll clear that out. So AB, I've got the square root of negative 4 plus 3 squared plus, parentheses, negative 2 minus 2 squared. Alright, the square root of negative 3 plus 1 squared plus 2 minus 3 squared. It's 2.2. AC is negative 4 plus 1 squared plus negative 2 minus 3 squared. 5.8. Alright, I'll go to DE. So negative 5 plus 1 squared plus 0 plus 1 squared is 4.1. So I have two congruent segments here. So AB is congruent to DE. Alright, let's go to EF. Would be nice if they were all congruent in the order, but we'll see. Negative 1 minus 0 squared plus negative 1 plus 3 squared. It's 2.2, and they're going to be in the order. So BC is congruent to EF. Okay, and last DF. Negative 5 minus 0 squared plus 0 plus 3 squared is 5.8, which is what we need. If any of these, if just one of them comes out where it's not congruent, then these triangles are not congruent. We are similarly going to write the same thing for our final statement over here, which is actually the answer. So I'm actually going to open that one back up just to kind of look at it here. So this is our final statement. Pretty much the same. So since the three sides side lengths, let's say, of each triangle are congruent, by side triangle congruence theorem, are triangles BCA and EFD are congruent, and therefore angles BCA and EFD are congruent because corresponding parts of congruent figures or triangles are congruent. Alright, so day 2 of these notes, we will finish talking about coordinate proofs with triangles specifically today. We're not done talking about coordinate proofs in general. Alright, so these are just a slightly different approach here because we now have something that says prove or disprove this statement, which means it's possible that the statement is not true at all. So we're going to go ahead and look at what we've got and then decide if the statement is true or if it is not true. So we have a triangle here with vertices. Let me make sure you can see the whole thing here. Yeah. All right, with vertices R, S, and T. So we're going to go ahead and graph it. If they give us a coordinate plane, we probably want to graph it. It'll probably help. S is at 1, 4. T is at 4, negative 5. Straight edge. Always use your straight edge. Alright, the question says it is an equilateral triangle. Well, an equilateral triangle, as you know, is a triangle with 3 congruent sides. These do not look like they are congruent at all. So we are going to, if we can prove that just one pair is not the same, then we have shown that it is not, in fact, an equilateral triangle. So we're going to look at what we think. I think that RS is probably not congruent to ST. We're going to use the distance formula just like we did the day before. Set these up. So RS is negative 2 minus 1 squared, again using the distance formula, and negative 2 minus 4 squared. S, we've got 1 minus 4, which is the Tx value, plus 4 minus negative 5, so plus 5 squared. Okay, we're going to plug these in and see what's going on here. I'm going to kind of scoot this over. Again, so negative 2 minus 1 squared plus negative 2 minus 4 squared. And remember, what we're trying to get is, we're trying to prove or disprove this is an equilateral triangle. It doesn't look like one, so I'm thinking I'm going to be disproving it. Alright, so let's plug in the second segment here, ST. 1 minus 4 squared plus 4 plus 5 squared. And I get 9.5, just as I thought. These two are not congruent, so therefore this is not an equilateral triangle. So since RS is not congruent to ST, triangle RST is not an equilateral triangle. Alright, if you are working on these yourself, you need to go back and grab problem example 4. You need to start working on that one on your own. So pause the video, work on example 4, and get it so you can see the whole thing in case you don't have a copy there. So you need to work on example 4. Example 4, the triangle with vertices A, B, and C is a scalene triangle. A scalene triangle is a triangle where none of the sides are congruent. So I'm going to go ahead and graph it. Negative 1, 3, 2, 1, 0, negative 2. If any of these look congruent, that's probably where I'm going to start. I don't actually think they're going to look congruent, so that means we might be proving this one, not disproving. So scalene triangle, all 3 of them have to be different lengths. So to prove that they all have different lengths, we have to find every length. So we have to find AB, BC, and AC. Now, lucky for us, if one of them, I don't need congruence, I'm looking for lengths. If one of them comes out with the same length, then I can stop there, because if any of them are congruent at all, it would be either isosceles or equilateral. Alright, so I've got my vertices up here. Using, again, the distance formula, we're going to use that a lot with coordinate proofs. Negative 1 minus 2 squared plus 3 minus 1 squared. Okay. And BC, 2 minus 0 squared plus 1 minus negative 2, so plus 2 squared. And last AC, negative 1 minus 0 squared plus 3 minus negative 2, so plus 2 squared. Okay, now let's type all these in. Negative 1 minus 2 squared. If you get any of these incorrect typing them in, normally it's a parentheses issue, because if you don't put parentheses, your calculator doesn't realize that that's a negative times a negative. So don't forget any of your parentheses. .6. Oh, right here. These two are actually congruent, so I can stop. I don't have to find AC. These two are actually congruent. So I'm actually disproving, not proving. Remember, in geometry, things might look like they are something like scaling, but that does not mean they are until you actually prove it. Since AB is congruent to BC, triangle ABC is not scaling.